Hey everybody, so really when we're taking a look at the chemistry this year, we're really going to be taking a look at compounds. And that's the world we live in. We live in a world of compounds. And just look at the earth here, the continents, the oceans, the water. All this stuff is really pretty much made of compounds. The water that's it's got salt in it, the oceans, it's all compounds. The thing that isn't compounds is the air that we breathe. That's made of nitrogen and oxygen. So there are a few areas of the world that we're really just dealing with elements here. But for the most part, we're all dealing with compounds here. The minerals, the rocks and minerals that were made up of compounds. Anthracite compounds, your compounds. All the materials that make us up, our blood and lipids and proteins and all these materials, the carbohydrates that make us up are made of compounds. You go into the cells from which we're made, and you look at all the little cells and everything and all the parts in the cells. These are all made of different types of compounds, all kinds of organic materials. Think of it, the proteins, the DNA, again, the carbohydrates, even so much of us is water, by the way. So what we've done, we started taking a look at compounds and last couple lessons, and we broke sugar down into carbon and water. These are we saw that compounds can be broken down chemically, can be broken down into simpler materials. We also broke water down. I showed you that as well. It's on the electrolysis of water. We broke this down into hydrogen gas and also oxygen gas. So what exactly are compounds? Well, they're single unique materials formed from two or more elements and are very different from the elements from which they are made.
Okay, so we live in a world of compounds, and I've just got a bunch of materials here for us to begin to, I don't know, think about them and understand them a little bit. I've got compound water over here. I've got some sugar. I've got salt as a compound. Salt is called sodium chloride. I've got another compound here, iron oxide. Okay, you know that as rust with an orange powder right in there, reddish brownish orange powder. I've got a compound here called magnesium sulfate, which comes from a mineral known as gypsum, very common mineral. And I've got a bunch of elements here too. I've got the element sulfur over here. I've got the element carbon. I've got three gases here: oxygen, hydrogen, nitrogen gas. What else do I have here? Oh, I've got some iron here. Iron is this, magnetic metal. Okay, it sticks to the magnet. There we go. I've got some nickel here. These Canadian coins are actually made of nickel, the element nickel. This is tin. Tin's pretty cool metal. It really is very malleable, bends very easily. And this is magnesium. This is a metal called magnesium. We're going to have some fun with that later in the week. Here's some chunks of aluminum. You may be familiar with aluminum foil, of course, but these are actual big chunks of cubes of aluminum here. I've got lead, all right, and lead weights, of course. Maybe you're familiar with those. It's a very dense metal. I've got copper here. You're probably familiar with that. Pretty familiar metal, used in pipes and all kinds of other things. And this is this is zinc. Okay, I can see the symbol on it. There we go. Zn, that's zinc. So we've got a bunch of elements here. We've got compounds, but we want to talk about compounds. Now, compounds, what's really interesting about them is that they are nothing like the elements from which they're made. I want to stress that point. Like take water, for example. We know it's made, we broke it down. We know that this is made of hydrogen and oxygen gas. Water is nothing like hydrogen or oxygen gas. We've got sugar here. Sugar, we know, is made of carbon and water. Water is made of hydrogen and oxygen. So sugar is basically made of oxygen gas, hydrogen gas, and this material carbon. Is this anything like sugar? No. How does that happen? How do we take like these three things here, okay, or take water and take carbon and somehow turn that into sugar? That's what's magical about chemistry, is you can take something like water. Plants do this, by the way. They take water, they take carbon from carbon dioxide, and they turn it into sugar. That's magical. That's unbelievable. How do you get something? You got iron oxide here, rust. This is nothing like iron or oxygen. You're looking at it. It's this reddish orange powder. Okay, is it anything like this solid, hard material called iron? No, it's nothing like that at all. And it's certainly nothing like oxygen. Oops, just dropped it. I mean, it's even lost its magnetism. It doesn't even have any magnetic ability anymore. Let's see if I can get the magnet under here. I'm trying to do this with one hand, so it's kind of hard. But you can see that nothing's moving here. Okay, so it's lost its magnetic abilities. It's nothing like oxygen. It's nothing like iron. It's nothing like the materials from which it's made. Oh, I've got the magnesium sulfate over here. I mean, look at this white powder, this white material here. Is that anything like, it's magnesium sulfate, so it's made of magnesium, it's actually made of oxygen, and it's made of the element sulfur as well. And there's nothing like oxygen, obviously, and it's nothing like the metal magnesium over here. It's nothing like this. And it's certainly nothing like sulfur either. It's totally different. But it is a single material. It is not three materials, it's just one thing, okay? As is water or sugar. Look at salt. Salt is sodium chloride. It's made of the metal sodium, and it's made of also the element chlorine. And somehow they're put together to make this compound that we know and love. We have it on so many foods and snacks. We love salt, okay? And yet it's made of two very nasty things. Sodium is a really nasty metal. It has to be stored in oil. If it's exposed to air, it instantly bursts into flame, or water, it instantly bursts into flame. Look at Clorox here has chlorine gas, and you've probably smelled that before. That's really nasty stuff. So you take chlorine gas, you take sodium, and somehow that gets turned into this material that we have on a lot of our snack foods, and just we love the taste of it. It's in the ocean. I mean, chemistry is magical. I mean, think of it. Really think about this. I gotta tell you, we are basically made of proteins and fats and lipids and carbohydrates and a lot of water and things. We are basically made of, and DNA and all these organic materials, we're basically made of just four elements: carbon, oxygen, hydrogen, and nitrogen. How do those four things? I know there's other things that we have too that are in us, iron, and then there's calcium and sodium and other things, but basically we are made of just these four materials, these four elements. How do you turn these four elements into us, into living things? It's really amazing. Chemistry's magical. So that's what we're trying to figure out here. We live in a world of compounds. How do we get them? How do we get these materials that are nothing like the elements from which they're made? Well, the key is we got to make molecules. We got to take the atoms of these elements and we got to make new particles called molecules. And when we make new particles called molecules, then we get compounds. But how do we make the molecules? How do we break molecules apart? How do atoms come together to make this happen? So let's take a look at what molecules are first.
So molecules are single particles made from two or more atoms joined together in a specific way. So there's an illustration of a water molecule, two hydrogen atoms, one oxygen atom. This is an illustration of a sugar molecule. It's got 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms. This is a molecule, one particle of rust, two iron atoms, three oxygen atoms. This is actually a caffeine molecule. It's got nitrogen, carbon, hydrogen. So what questions are we left with regarding compounds? Let's just say them again. We got, why do atoms bond to form molecules to get compounds? How do atoms bond to form molecules to get compounds? Why do atoms bond in these specific ratios like H2O, two hydrogen atoms, one oxygen atoms? And how can that be changed to get different molecules? How can molecules come apart? And why are compounds so different from their elements? And you look at the periodic table here. Let's start talking about elements. There's they're the simplest materials. They're made from just one kind of atom and are the building blocks for all other forms of matter. And those are some of the basic three things to think about when we're thinking about elements. And you see the periodic table here. Let's take a look at one. And there's a lot of them are metals. Most of the elements are metals. Some are non-metals, and there's some that are really familiar: carbon, hydrogen, oxygen, calcium, things, iron, things you've heard of before, aluminum, and then some, a lot you haven't. Now there's 92 naturally occurring elements, even though there's a lot more on the periodic table. Many of them have been made in laboratories. They're very unstable, but there's just 92 natural, simple materials called elements. And what makes an element different from one another? Well, they're just made of just one kind of atom. Like carbon is made of carbon atoms, and the atoms are the tiniest particles of an element that can still be that element. And they're made of specific combinations of protons, neutrons, and electrons. We're going to be learning about atoms, and this is what makes elements different from one another. Each element is made of its own specific type of atom. Hydrogen is made of hydrogen atoms. Carbon is made of carbon atoms. Nitrogen, nitrogen atoms. Oxygen, oxygen atoms. Copper is made of copper atoms, and so on. So, why is all this important? Well, in order to understand how elements combine to form compounds, we need to understand how the atoms of these elements join to form molecules. If there's no molecules, there's no compounds, there's no water, there's no us. Just a universe of elements. Think about it. So, to understand how atoms of elements bond to form molecules, to get compounds, we need to understand the makeup of atoms. And that's what's coming up next. So, thanks for watching and stay safe, everyone.